Hello there, our wonderful and highly estimable viewers on this favorite YouTube channel, Mathematics by Abu Zainab. That special channel created for you and I to demystify mathematics and tackle the age-long phobia associated with this all-important subject, one topic at a time. Today's class promises to be very interesting, exciting, and most importantly, fun, as we are learning or continue in our learning of quadratic equation, however, with a further mathematics flavor or a different perspective indeed. In the previous lessons, we have learned how to solve quadratic equations using three of the available methods, and these are factorization method, completing the square method, and general formula method. So the aim of all these methods is to get the roots of the quadratic equations given, or find the solutions or the answers. On the other hand, you can also be asked to generate the original equation while being given the roots. So that's like a reverse process. You are given the answers and you are required to generate the original question that produced those two answers. And that is the theme under today's lesson. So dive along and let's have fun. Recall that a quadratic equation is usually of the form ax squared plus bx plus c equals 0. And if you want to have a coefficient of 1 there for the x squared, we divide through by a. Hence, we have x squared plus b over a x plus c over a equals 0 over a, which of course reduces to x squared plus b over a x plus c over a equals 0. Let's take note of this derivation now. Now let's suppose we are given the root of equation as alpha and beta. So let alpha and beta be the roots of the quadratic equation. So we are going to walk back from these answers to the question. Of course, remember, we are meant to have two answers. So let's say x equals the first answer, and x again is also equal to the second answer. Remember, in the previous classes, we said x equals to a particular value or x equals another value. So working backwards now, this means x minus alpha is 0, and also x minus beta is 0. Now, if each term is 0, it simply means the product of the two will also be 0 necessarily. Hence, x minus alpha times x minus beta will also be 0. So, if we open these brackets, we are going to have x squared minus beta x minus alpha x plus alpha beta equals 0. Then factorizing there, we have x squared minus, here we have alpha plus beta x plus alpha beta equals 0 as well. We've also, that's the quadratic equation that we are required to derive. So let's do a simple comparison between these two boxes now, term by term. For the x squared, we have coefficient 1 here, likewise 1 here. For x, the coefficient there is minus alpha plus beta, and the coefficient there is simply b over a. Hence, I can say then alpha plus beta equals minus b over a. Then lastly, the constant being compared, alpha beta here, will necessarily be the constant there, c over a. These are very important tools that will be needed in subsequent work in this aspect of this topic. So in summary and in simple English, that means if you are given two roots and you are asked to generate the quadratic equation or to construct an equation in x or to form the equation from which those roots are gotten, loosely speaking, we can get it from it by saying we have x squared minus the sum of the roots multiplied by x as a twice. Look at the roots. Alpha and beta are the roots, and this is their sum. So x squared minus the sum of the roots times x plus this product of roots, and that equals to 0. So in other words, you don't have to go through all this stress. Once you are given the two roots, just add them up and find their product, and then substitute into this equation, and you're good to go. Without wasting much time, let's delve in proper into the stuff that this topic is actually made of. So, let's form equations in X whose roots are, let's say, 3 and minus 7, 2, minus 2 and plus 2, 3, 1 over 4 and 2 over 3. Okay, these three should suffice to explain the concept. Now, certain quadratic equations have been solved, and these are their roots. What are the equations? So we're looking backwards. Without mincing words, let's go back straight to the formula just given, which is what? S squared minus sum of roots times x, then plus product of the roots equals 0. So for the first one there, we had the roots as 3 and 7. Just slot in directly. S squared minus, the sum will be 3 plus minus 7 x, and the product will be 3 times minus 7 equals 0. So we have x squared minus 3 plus minus 7 means 3 minus 7, and that's minus 4x. It's minus 4x, okay? Then plus 3 by minus 7 is minus 21. So lastly, we have x squared plus, because minus times minus is plus, 4x plus times minus, minus 21 equals 0. And that is it. It's as simple as that. In other words, if you solve this quadratic equation, you will necessarily get 3 and minus 7 as your root or answers. Without wasting time, let's go straight to number 2, which is fun. Number 2, we have minus 2 and plus 2. So we are going to have s squared minus 2 plus 2 x, then plus minus 2 times plus 2 equals 0. Again, the roots are minus 2 and plus 2. So their sum will simply be in this first bracket, and their product will be the second bracket. So you have x squared minus 2 plus 2 is 0 times x, plus minus 2 times 2 is minus 4 equals 0. And that results in x squared minus 0x, everything here vanishes, plus times minus 4 equals 0 again. And that is it. It's as straightforward as that. Very, very simple. Then lastly, we've got the fractions. So here we have the same approach, x squared minus the sum of the roots, 1 over 4 plus 2 over 3 x, then plus their product, 1 over 4 times 2 over 3 equals 0. No difference whatsoever. So we go x squared minus the sum of this. We have the LCM being 12. So we have 3 here plus 8x. I take it for granted that you understand how to sum fractions. Then plus, here we have 1 over 6, because that's 2 over 12 equals 0. And that gives us x squared minus 11 over 12x plus 1 over 6. I remember in one of our previous videos when I said that we have to clear these fractions. To clear fractions, you multiply through with the LCM of the denominators. The denominators here being 12 and 6, and the LCM is 12. So multiply through by 12, you have 12x squared minus 11x plus 2 equals 0. By standard, you are not expected to leave your answer in this format whatsoever. You are meant to leave it as integral coefficients, but not as fractions. But if it's a multiple choice and you see fractions in your answer, that means you are not expected to actually proceed further. But by standard, you are meant to linearize by making sure that we have non-rational functions. And basically, that is the end of our lesson on this aspect of the topic, forming quadratic equations with the given roots. It's very simple. All you need to do is to find the sum of the roots and find the product and insert at the respective places here in this given equation, and you resolve the resultant equation. If you find this class very interesting and fun, which I believe you should, stay tuned for the next video. But don't forget to subscribe, like, share, and importantly, put on your bell so that you'll be the first to know when our next video is dropped. Thanks and stay blessed.